Hello my dear students, welcome to lecture number 11 on motion. Myself R.V. Jambagi. Before starting this lecture, I am seeking the apology and allow me to correct myself because a small error occurred during the previous lecture. Let me correct once again. By that we can move to the next part of the lesson. Okay. So this was the problem where a small error occurred. So a bus decreases its speed from 80 km per hour to 60 km per hour in 5 seconds. Find the acceleration of the bus. So we took the initial velocity 80 km per hour into meter per second. We got 22.2 meter per second, and on the other hand final velocity is taken as 16.6 meter per second, and time being 5 seconds. What will be the acceleration? So this is the point where the error occurred. I again seeking the apology. So this is the happen. We need to correct. First, initial velocity will be 22.2 meter per second. V will be 16.6 meter per second. Okay. So I have written and go on solving this. So just ignore these steps. So let's try to solve once again. So V will be, that is 16.6 meter per second minus 22.2 meter per second divided by 5. That gives you minus 5.6 divided by 5. That gives you the result minus 1.12 meter per second square. That will be the acceleration of the bus. So since the bus decreases its speed from 80 to 60 km per hour, therefore acceleration will be negative. So this is the correction I am making at. Hope you satisfied with that. Let us take the main part of today's lecture, that is graphical representation of motion. Generally, graphs provide a convenient method to represent the basic information about a variety of events. Generally, graphs are providing a convenient way or convenient method to present the basic information about a variety of events occurring. So you probably seen many graphs such as this. You probably seen this first graph, probably second and third graphs, these two. You probably seen these type graphs too. You can see many graphs in your day-to-day life. I'm listing only few here. I hope you observed all those. As we know, the linear or line graphs, these are called linear or line graphs, which help in solving linear equations having two variables. Solving the linear equations, these graphs are helping us, and hence they are very much important. Okay. No, the line graphs helping us in solving linear equations having two variables. To describe the motion of the object, we use these graphs. We are using these graphs to describe the motion of the object or a body. The graphs which we are learning here are distance time graphs and velocity time graphs. So here we are focusing on distance time graphs, as well as velocity time graph. Let us learn first the distance time graph. The graph in which x-axis is represented by time, x-axis is represented by time, and y-axis is represented by the distance. Such graph is known as distance time graph. That is called as distance time graph. The graph in which x-axis is represented by time and y-axis is represented by the distance. Okay, you already know that a graph has two axes. One is y and other one is x. This is x-axis, this is y-axis. So here x-axis is represented by the time and y-axis is represented by the distance. Such graphs are known as distance time graphs. The variation in the distance with time for an object moving in straight line is represented by this graph. The variation in the distance with time of the object, the variation of the distance with time for an object which is moving in straight line. The object which is moving in straight line, that is represented by this graph. We are considering this graph for the object which is at rest. So object when it is at rest, how this graph moves, and when the object is in uniform and non-uniform motion, how this graph behaves. Okay, or the behavior of the object which is shown in this graph. Hope you are getting all these. Okay. The first one, when the object is at rest. So in other words, when no movement is there, the object which is at rest, there is no movement means what? The object is at rest. So when the object is at rest, then the distance time graph is a straight line which is parallel to the x-axis or time axis. Okay, so in this case, the line which is overlapped on the x-axis because the object is completely at rest, and hence that line is overlapping on x-axis. Assume in the second case, object traveled certain distance of 3 meters like that, then it maintains some amount of rest thereafter, then the graph looks like this. Okay, so this is the straight line which is parallel to the time axis. Hope you are getting this graph right. When the object is at rest or when there is no movement, the distance time graph shows a straight parallel line which is to x-axis, straight parallel line to x-axis or straight line parallel to x-axis. Hope you are getting this thing right. Now the second part, when the object is in uniform motion. When the object is in uniform motion, then the distance time graph is a straight line from the origin. This is also a straight line, but it is starting from the origin. It is starting from the origin O. Okay. When the object is in uniform motion, the distance time graph is a straight line which is passing from the origin O. If you draw the slope to these graphs or these axes, time and distance axis, you will get the speed. If you draw a slope, how do you plot a slope? You already knew it. So if this is the point, so just I am drawing this like this. Okay, and this is for x-axis and this is for y-axis. So this has to be the point D1 here. This is D2. This is T1 and this is T2. If you say this point as A, this point as B and this point as C, the slope gives you the speed how, which is equal to here AB, this line AB on y-axis divided by BC, that is x-axis, and hence y by x, which is equal to D2 minus D1 divided by T2 minus T1. This gives you that the distance, variation in the distance by time, that gives you velocity. This is how we are plotting the graph. Here in this case that is speed, that gives you speed. If instead of distance you use displacement, then that gives you velocity. Okay, this distance time graph turned into displacement time graph. That's why I have written here. Note that the same can be applied to displacement time graph, which gives you the slope of that gives you velocity. I hope you are getting this. The next part, that is when the object is in non-uniform motion. When the object is in non-uniform motion, then the distance time graph varies with time at different points. It is varying differently at this point, that is different, this point different, this point different, this is different. So similarly, so on. When the object is in non-uniform motion, you cannot predict the distance time graph. So as per the distance time graph, it varies. The distance time graph, the distance along with time varies at different points. Therefore here the slopes, if you want to plot, they are not same. Okay, this is all about the distance time graph when the object is at rest, when the object is in uniform motion, and when the object is in non-uniform motion. Hope you are okay with this concept. The next part, that is velocity time graph. The graph in which x-axis is represented by time and y-axis is represented by velocity. Then that kind of graph is known as velocity time graph. Assume this is the graph, this is x-axis, this is y-axis. Y-axis is represented by velocity and x-axis is represented by time. Such graph is known as velocity time graph. The variation in velocity with time, the variation in velocity with time for an object moving in straight line is represented by this graph. So this graph showing that when the object which is moving in straight line, the variation in velocity with time given by this graph. Here we are considering this graph for an object in different modes. One is in uniform motion or uniform speed, and second one is in uniformly accelerated motion, in uniformly retarded motion, and in non-uniform motion. We are plotting the graphs when the object is in uniform motion or uniform speed, in uniformly accelerated motion, uniformly retarded or decelerated motion, and in non-uniform motion. I hope you got all these points. These things will be discussed in the next period. Till then, take care of yourselves. Bye bye.